So now that we've covered the flights portion, flights package, let's take a look at some of the other packages. They won't take as long to cover as flights. These are the other 3 microservices that are defined here in this particular functional implementation of the FLApp case study. As you can see here, we have the exchange package, the airport package, and the airline package. Let's take a look at airport first. It's really, really simple. And in fact, it's almost identical to what we had in the monolithic version. The main difference, of course, being that unlike the monolithic version, which just had an implementation of an object and a repository using JPA, we kind of foomp it up a little bit to make an application. So we now have an airport application. And of course, we also have an airport controller, because this will be contacted by the flight app gateway service, which is kind of the entry point into everything. As you can see here, we have a whole bunch of different annotations. The most important one here is that we are enabling discovery client. So that says this particular class, this particular application is going to be discoverable. So discoverable microservice. We say where you can find the implementation, other things that it depends on, like the airport application and the components implementation. We're going to enable the use of Java persistence API properties and repositories, saying where to find that. So that is an instruction to Spring to know how to use ways to configure those things automatically. And then we say where to find information about the client properties and the database properties. And if you go and look in the resources portion over here, you can see we have basically the airport properties, which is this thing defined here, which says, for example, use Hibernate H2 as the database, call this microservice airport. And here's where you can find the schema for this thing. So that's the schema. That's basically the mapping between the 3-letter airport code and the name of the airport. And then we have the schema itself, which is just defining what the table is going to be laid out in our database model. And there's some other stuff here, database properties. This is just saying some things about the database that we're using. You can see that we're using Hibernate. We've got very simple password just for testing, nothing fancy here. And some other things that you would use if you wanted to configure and provision the way that the database is going to behave. So that's how we do the airport application. As always, we've got a main entry point. We run the airport application class. Everything springs into motion. We're up and running. There's an airport controller, which works the way that all the controllers work. This is a REST controller. It also is marked as being cross-origin, which basically is something that's required for Eureka redirection. And then we define the fact it's got an airport service as its implementation. And the main method it exposes is just called get airports. And that forwards to the get airports service method to do the heavy lifting. Here's also a little request that we put in here for the Eureka control panel. I'll probably show that in a future class when we're not pushing short on time. But this just basically returns information about what microservice this is. This is the airport microservice. Here's the airport service, which implements the controller. It's connected to an airport repository. And as you can see here, it's really simple. When someone makes a get airports call on the airport controller, it calls get airports on the airport service, which turns around and calls find all on the repository. And here's the repository. It's really simple. Airport repository extends JPA repository, mapping airports and strings, and find all just goes ahead and is implicitly defined as part of JPA repository. And if we want to know what airport looks like, we go over to the model. You can click on airport. You can see airport is just basically this kind of what we call a plain old Java object or a POJO. And this POJO just defines an airport code and an airport name. So again, very straightforward, very canonical. Things always kind of look and feel pretty much the same when you're using JPA, and that's by design. That's a good thing. So that's the airport service and the airport controller and the airport application. You can see there's not a whole lot going on there. It's mostly just kind of a front end to the database that we get through JPA. The exchange microservice, also very canonical. It has pretty much all the same annotations that we just saw for airport. I think they're pretty much identical, except that they point to different property files. For example, we have our main method, which calls Spring application run. That's all the same. Here's the Exchange controller. Again, no real big surprise here. It is going to be implemented by an auto-wired Exchange service. We have that info method for the Eureka control panel. And we've got really one method here called getRate. And given a from currency and a to currency, it goes ahead and forwards to the service. We'll look at that in a second. And then depending on the results, it'll go ahead and return the results appropriately based on what's happened. Here's the Exchange service. Again, it's a service, no real surprise there. That means it can be scanned and auto-detected and wired. It's going to be auto-wired to the Exchange repository, which is what stores the mapping of currencies. Again, in a real-world production implementation, this would be connected to some kind of live currency conversion service, but this is good enough for our purposes. And then there's a method called getRate, which given a from currency and a to currency, looks up in the repository to get that mapping, and you get back an exchange rate object. And here's the Exchange repository. And you can see here, it again is just, sort of boilerplate code using JPA repository to map long and exchange rate. And here's the method that does its thing. And then over here is the exchange rate POJO, the plain old Java object. And you can see it's got an ID, a from currency and to currency, and an exchange rate. And all of that information is configured over here in the resources file. Here's the schema. And then here's the faux exchange rate, where we're showing the mappings between different currencies and what their relative relationships and values are to each other. Okay, so that's pretty straightforward. Let's take a look at the last piece of the puzzle. This one's a little bit more interesting, and that's why I saved it for last. So this is the airline implementation. And you can see that what we have here is we have a common folder that's shared by AA and SWA. And of course, if I added more airlines, we'd have folders for them too. It has a controller, which is the usual thing. It is auto-wired to the airline service. It's got an info method. It's got find flights and find best price and find departure dates. Those are the endpoint methods it exposes to the clients that are going to use it, which in this case would be the flights app gateway. Here's the airline service. It's a service, nothing really surprising there. It's auto-wired to a repository. Gee, that's looking familiar. And then here's find flights. You can see it just goes and looks up in the database to find what it is. Here's find best price. So find best price turns around and calls find flights, although it could just call this, but it calls find flights. And then it goes ahead and it runs that code to find the minimum priced flight for flights that are for a particular airline. You recall we used the same algorithm later in the context of the flights service method that did this stuff, the flight service implementation. But at that point, it's consolidating all the best prices it got from all the other microservices. So the code is actually kind of duplicated here. If I put my mind to it, I could probably factor this code out and make that be reusable. But I think I may also have some fun showing different implementations. So I don't know if I want to have them be identical just to show you different ways to do things. And then find departure dates, again, just calls into the repository. And here's the repository. As you can see, these are just JPA calls. The only one here that's really even the least bit interesting is the one for find departure dates, which actually declaratively specifies a query, which uses select from looking up in the table to find things that map from the departure airport to the arrival airport ordered in a sending order by date. So again, kind of pretty straightforward. The last piece of the puzzle are the applications. So remember we have Southwest and we have American Airlines. Those are handled through little application classes. And they are really identical in everything except the properties file that they look for. So here's the one for American Airlines that looks at the AA properties file. The one for Southwest looks for the SWA properties file. And of course, those property files are found here in the appropriate resources portion. So here's SWA properties, and here is AA properties. And you can see the only real difference is that they have different prefixes. This says AA-airline, and this says SWA-airline. And oh, by the way, if you recall back when we wrote that helper method down here in flight, you look at flight service, and you take a look up here where we had the discovery service. Let's see if I can find there's one here about get, let's see, what was that called? Here we go, get airline services. Notice it's checking to see if the string of the name contains the word airline in it. And that's where the airline is coming from. AA-airline, SWA-airline. Those are the places where those things are defined. So what's cool about this is we can have quite a bit of common code. And if I put my mind to it, I could probably even refactor this further to have a common application file that's even more reusable, but it was reaching a point of refactoring that I thought was getting out of hand. So I left it the way it was. But this will give you a kind of a flavor for how the microservices version of this app has been defined. And what's really fun is to kind of go back, if you have time, and go back and take a look at the video that talks about the monolithic implementation. And you'll see that there's tremendous commonality. A lot of the code is reused. A lot of the implementation code is reused. A lot of the configuration information is reused. The main difference here is we take the various objects that were defined in the monolithic version and we split them off into their own microservices, which can then be run in different physical processes or virtual processes, whatever processes you think of being physical or virtual. They can run in different processes on different computers in a cluster. And we're not going to be restricted to everything running in just one address space in one monolithic implementation. Now, as to whether that's a winner or not, depends on a whole bunch of different factors. And that's a discussion for another time. But the key point here is that you can see how easy it is to take, a nicely structured object-oriented design for a monolithic example of a flight listing app and transform it into a nicely structured object-oriented design microservices version. And the reason why it's so easy is because it was well designed in the first place. So we just have to spend a little bit of time kind of splitting things up and defining a few extra application files and controller files and so on. But everything else is very similar. And if we really played our cards right, we could probably reuse a lot of this code without skipping a beat. I didn't want to get that carried away to have it all in the same repository because it got confusing. But you can imagine doing that if you needed to and being able to mix and match between co-located monolithic implementations and microservice-based approaches without a whole lot of extra work.